Today we are going through Physics 062542 May-June 2022 paper. Question number 1. Figure 1.1 shows an electrically powered bicycle. When fully charged, the battery can deliver a power of 600 watts for 60 minutes. Part AI says calculate the energy in joules stored in the battery when fully charged. So the things we are given in the question is power, which is 600 watts, and we're given with the time, which is 60 minutes. We can convert it into seconds, which is going to be into 60, and then we have a formula: power equals energy divided by time, and we can rearrange this formula to find out E. So we have energy equals power, which is 600, into time, which is 60, into 60. So we can put this in our calculator, and we get our answer as 2.16 into 10 raised to power 6. Part 2 says state the form of energy stored by the battery, and we know that the form of energy which is stored by the battery is chemical energy. Chemical energy, and we get 1 mark for this. Part B says the bicycle has a motor with an electrical input of 250 watts. Calculate the time for which the battery can power the bicycle. So we can use the same formula here, which is going to be power equals energy divided by time, and we can rearrange our formula to find out T. So we get as energy divided by power equals time, and we found out energy in the first part, which is 2.16 into 10 raised to power 6. We can just plug in our values and find the value of T. So energy, which we found out, which is 2.16 into 10 raised to power 6, and power, which is 250 watts, and we get our time from this. So we can put this in our calculator: 2.16 into 10 raised to power 6 divided by 250, which is gonna give us 8640, and we can write our units as well, which is going to be seconds. Part C says consider this bicycle compared to a small motorcycle. State 2 environmental benefits of electrically powered bicycle. This is a pretty straightforward question, and we can write normal points like we get protection against air pollution, protection against air pollution, and as it is environmental benefit, so we can say that it could be charged through green energy. We get 2 marks for this, and we're done with question number 1. Question number 2. Figure 2.1 shows an object of mass 2 kg on a bench. This object is connected by a cord passing over a pulley to an object of mass 3 kg. The 2 kg object is released from rest and accelerates at 4 meters per second. Part A says calculate the resultant force acting on the 2 kg object. So we are supposed to find the resultant force acting on 2 kg object, which is this one. So we know the formula for resultant force, which is going to be F equals ma, and this F represents our resultant force. So we have the value of m, which is 2 kg, and we have the value of acceleration, which is 4 meters per second square. So we can plug in our values and find out the value of resultant force. So 4.0 into 2.0 will give us our resultant force, which is gonna be 8. So we can write our force as 8 Newton with the SI units. Part B says calculate the upward force F exerted by the cord on the 3 kg object. So we can see here, we can draw it as a pulley, which is going to be this and this here. We can say that this is our 3 kg object and this is 2 kg object. So when the object is released from rest, this side of the pulley will go down and this side of the pulley will go up. So what will happen is we'll get a formula as tension minus mg for this case, and for this case we will have is mg minus tension, as this is going down. If it was opposite, the 2 kg was going down and 3 kg was going up, so this would be mg minus tension. But in this case we have mg minus t. The formula we are going to use here is sigma of forces, which is sum of forces, equals ma. Sum of forces will be this, mg minus t equals ma, and we know the value of m, which is 3 kg, and we know the value of a, which is given in the first part, which is 4. So we can plug in our values, 3 kg, and then gravity is 10, minus t equals mass is 3 kg again, and then acceleration is 4, which was given in the first part. We can rearrange our formula. We will get 3 into 10 minus 3 into 4 equals t, and we can find out our value of t by using calculator. 3 into 4, which is going to give us our tension as 18. And if you go and look at the question, in the diagram it says that tension is force F, which is given here. So that means tension equals force F. So we have to find the value of F in this part, and we can write our answer as 18 Newton. Part C. The object has a constant acceleration. Part I says show the speed of the object 0.8 seconds after the release is 3.2 meters per second. So when they mention constant acceleration, we have to use the formula v equals u plus a t. And we know that the system was initially released from rest. So our u is going to be 0, which is initial velocity, plus a is 4 and t is 0.80. So we get our final velocity here, which is gonna be 4 into 0.80, 3.2 meters per second, which is same as the question. Part 2 says a card of width 2 centimeter is fixed on 2 kg on the 2 kg object. As the 2 kg object moves to the left, the card passes through a beam of light that is perpendicular to the card. Use the speed given in CI. Calculate the time taken for the card to pass through the beam of light. And the speed we found out was 3.2. And we can use the distance, which is the length of the card given, 2.0 centimeter. So our distance is going to be 2.0 centimeter, and we have to find t. So the only equation which relates these given values is speed equals distance divided by time, and we can rearrange a formula to find out t. Time equals distance divided by speed. And don't forget to convert this into meters. So it's gonna be 2.0 into 10 raised to power minus 2 divided by 3.2, which is gonna give us our time. And we can put this in our calculator. 2.0 into 10 raised to power minus 2 to convert from centimeter to meter, and then we have to divide by 3 by 2, which is going to give us our answer as 6.25 into 10 raised to power minus 3. 6.25 into 10 raised to power minus 3 seconds. And we are done with question number 2. Question number 3. Part A says figure 3.1 shows water in a river moving parallel to the river bank at 4 meters per second and a canoe traveling in the river. The canoe travels at 2.5 meters per second relative to the water and heads at an angle of 38 degrees to the river bank. Draw a scale diagram to determine the canoe's resultant velocity and state the scale you used. So the scale we're going to be using is 2 centimeter equals 1 meters per second. And we can draw the same diagram which is given in the question. It's pretty straightforward question. The water is moving on this direction, so we're gonna draw 4 into 2 centimeter line on this side, and then we have one line over here which is going towards northwest, which is gonna be for 2.5 into 2 centimeter, and then we'll have our angle with the river bank, which is gonna be 38 degrees. Now we can draw our diagram here. First, we can draw our 8 centimeter line, which is gonna be like this. This is 8 centimeter. And then we have an angle of 38 degrees in between. So this angle is gonna be 38 degrees. And this line is for 5 centimeter. Now we can use our compass to draw an arc here, which will give us the line for forming resultant velocity. And we can join this from this side and join this from this side. This is going to be 8 centimeter and this is going to be 5 centimeter. Now to find out the resultant velocity, which they're asking in the question, magnitude of resultant velocity, we have to take this length, which for me is 5 centimeter, and we can write our answer here, 5 centimeter divided by 2, because we took 2 centimeter as 1 meters per second, so we'll get our answer as 2.5 meters per second. So 2.5 meters per second is our resultant velocity, and then it asks us that direction of resultant velocity and the angle should be from the river bank. So we're supposed to take this angle, and if we measure this angle by using protractor, we'll get our answer around 37 degrees. Question number 3, part B says the mass of the canoeist is 65 kg. Calculate her kinetic energy when traveling on still water at 2.5 meters per second. We know the formula for kinetic energy, which is half mv square, and we can plug in our values. We know mass, which is 65, we know v, which is 2.5, and we square this, so we get our kinetic energy. We can put this on in our calculator and find out the value. And our answer is gonna be 203. And don't forget to add the units for energy, which is gonna be joules. And we are done with question number 3. Question number 4. Part A says state and explain two features of liquid and glass thermometer that are necessary for linearity. There are many conditions. We can state two of them. One of it can be the diameter of capillary should be uniform, and the reason for that is so that the volume increase will be uniform. And for the second statement we can write, so expansion of liquid should be uniform with temperature. And the reason for this we can give is to ensure expansion per degree is constant. And these are the things which you're supposed to learn before the exam, and these are basic knowledge which the Cambridge examiner is going to test you for. Moving on to question number 4, part B. The value of heat capacity of hot junction of a thermocouple thermometer is important in ensuring that it can measure temperature changes very rapidly. Explain why. So the reason behind this is that the heat capacity of hot junction of thermocouple is very small. What happens is that the thermometer will reach the temperature of surrounding very rapidly. So we can write here, so the thermometer reaches the temperature, surrounding temperature rapidly. And we get 2 marks for this. Part C says the hot junction of a thermocouple thermometer has a heat capacity of 0.11. Calculate the thermal energy required to increase the temperature of the hot junction from 20 degrees Celsius to 345 degrees Celsius. Note that the degree temperature is given as in degrees Celsius, and we have to convert this into Kelvin. And to convert from degrees Celsius to Kelvin, we have to add 20 plus 273, and for the second one we have to add is 345 plus 273, and we get our new values as 293 and 273, 618. These are our new values, and for this question we're given with heat capacity. So the formula relating heat capacity is E equals mc delta T, where heat capacity is mc. We can write it as big C here. We know that heat capacity is 0.01, and the change in temperature is gonna be 618 minus 293, and we get our energy from this. So we can put this in our calculator. 0.11 into 618 minus 293, which is gonna give us our answer as 35.75, 35.75, which we can round it off to 36. So we have our answer as 36, and energy unit is joules, so we write J. And we are done with question number 4. Question number 5. Sound waves are longitudinal and electromagnetic waves are transverse. Part A says a sound wave used for medical examination has a frequency of 1.5 megahertz, which is 1.5 into 10 raised to power 6 hertz. And part I says state and explain what type of sound wave is this. And I have given a diagram here. You can see from 10 raised to power 4 till 10 raised to power 7 is ultrasound, and from 10 till 10 raised to power 1 till 10 raised to power 4 is sound, and from 0 till 10 raised to power 1 is infrasound. So in this case it's 10 raised to power 6, so it's ultrasound. We can write down our answer here, ultrasound, as the range of frequency is in between 10 raised to power 4 and 10 raised to power 6, or we can write 7. Part 2 says the wave travels through soft human tissue at speed of 1.3 kilometers per second. Calculate the wavelength of the wave in soft human tissue. So we have our frequency, which is 1.5 into 10 raised to power 6, and we have our speed, which is 1.3 into 10 raised to power 3 kilometers per second, meters per second. We have just converted this into meters, and we need to find wavelength, which is lambda. The equation which relates to the information given is V equals F lambda, and we know V, which is 1.3 into 10 raised to power 3, and we can rearrange this formula to find out lambda, which is going to be V by F. So it's going to be 1.3 into 10 raised to power 3 divided by 1.5 into 10 raised to power 6, which is going to give us our answer as 10 raised to power 3, and just going to divide with 1.5 into 10 raised to power 6 and give us our answer as 0.00086, which is going to be same as 8.66 into 10 raised to power minus 4. Part B says describe one use of X-rays in medicine. So we can write here the use of X-ray in medicine, which is scanning of internal organs. And we are done with question number 5. Question number 6. Figure 6.1 is a full-size ray diagram showing the formation of an image by a thin glass lens. Part A says determine the focal length of the lens. For finding the focal length, we need to measure the distance between these 2 points, which is going to be from the center of the lens till the point of focal. So if we measure this by ruler, we can see that this is 2 centimeter. Part B says circle 3 items in the list which describes the nature of the image formed. We can see here that the image is not formed on the same side, and you can see that the original size of the image is this, and the projected one is way larger than the actual size of the object. So we can circle enlarged as it's way bigger than the original object, and it's real, and we can see it has been inverted because it's not on the same side. Part C says state one feature of virtual image. So one feature of virtual image is that the image is upright, and you get 1 mark for this. And we are done with question number 6. Question number 7. Figure 7.1 shows a small plotting compass which is aligned with the magnetic field between magnet poles A and B of a U-shaped magnet. State the polarity of the poles, pole A and pole B. So this one is pole A and this side is pole B, and you can see the compass is pointing here for north and here for south. And according to the properties of magnet, you know that unlike charges attract and like charges repel. So that means if this is north, this is going to be south, and if this is south, then this is going to be north. So we can write our polarity here. For pole A, it's going to be north pole, north, and for pole B, it's going to be south. And we get 1 mark for this. Part B says figure 7.2 shows a wire placed between two poles carrying a current in the direction of the arrow. On figure 7.2, draw an arrow to show the direction of the force on the wire due to the magnetic field. So for this, we have to use our Fleming's left hand rule, which is going to be FBI, and your thumb is going to be F. Your first finger is going to be magnetic field, and your L is going to be the middle finger. So if you put them perpendicular to each other, you can see that your middle finger will be pointing here and the first finger will point from north to south, and you'll get the direction of the thumb, which is going to be upwards, which will be our answer for this question, the direction of the force on the wire due to magnetic field. Another part says that on figure 7.3, draw an arrow to show the direction of the force on beta particle due to the magnetic field. You can see that the motion of beta particle is outwards, and we have to use the same Fleming's left hand rule, which is going to be FBI, where this is going to be your thumb, this is going to be magnetic field, and this is going to be your direction of motion. So you can see your middle finger will be pointing here, and then you will have the magnetic field, which is going to go from north to south, and then you'll get your force as upwards. But the thing about this is that beta particle is negative, and whenever you have a negative particle, the direction of the force will change. It will be opposite. So instead of up, it's going to be down this time. So we can draw our arrow downwards. When we use our Fleming's left hand rule, there's a rule that when there is a negative charge, direction of force is going to be opposite when using Fleming's left hand rule. You can remember this part, and we are done with our question number 7. Question number 8. Figure 8.1 shows the electromotive force of 60 Hz alternating current power supply varies with time. Part A says calculate the time period of AC. We can see in the question that we are given with the frequency which is 60 Hz. So we need the formula F equals 1 by time period, and we can rearrange our formula and we get 1 by F equals time period. So it's going to be 1 by 60 equals time period. We can find our decimal value from the calculator, which is going to be 0.01666, which is recurring. We can write 0.017. 0.017, and our time period is going to be seconds. Part B says figure 8.2 shows the power supply connected in a circuit. Part BI says state the name of the component A. So we can see from here it's a diode, D-I-O-D-E, diode. Part 2 says in each time period of the AC, 1.5 into 10 raised to power 17 electrons pass through component A. The charge on one electron is 1.6 into 10 raised to power minus 19 coulombs. Calculate the average current in circuit during one time period. So we're given with N, which is 1.5 into 10 raised to power 17. We're given with charge, which is Q, 1.6 into 10 raised to power minus 19. And we are supposed to find I, which is not given, and T is given, which is 1 by 60. So the only equation which relates to these information given is Q equals IT. Q equals IT. And we can rearrange our formula to find I, which is going to be Q by T, and 1.6 into 10 raised to power minus 19 divided by the time, which is 1 by 60, and we'll get our answer as 1.6 into 10 raised to power minus 19 divided by 1 by 60, which is going to give us our answer as 9.6 into 10 raised to power minus 19 minus 18. So this is for one electron, and we have to multiply this by 1.5 into 10 raised to power 17 to get the average current. So we multiply this by 1.5 into 10 raised to power 17, and we get our answer as 1.44. Don't forget to add the units, which is ampere. Part C says mark with an arrow labeled E the direction of electron flow through component B, and the second thing it says that draw an arrow with labeled I the direction of conventional current in component C. So as we can see here, we're using a diode, so the current flow is going to be on one side, which is going to be here like this, and when the current tries to pass on the other side, the diode doesn't let it pass through it. So there's only going to be one side of flow, so we can mark here the current is going to be on this side, and for electron flow it's always opposite of current, so it's going to be on this side. We can label this as E and label this as I. Part D says figure 8.4 shows a circuit with component B and C connected to a direct current DC power supply of EMF 12 volts. The current in the circuit is this. Calculate the power delivered by the power supply to the circuit. So we're given with V, which is 12. We're given with I, which is 0.35, and we are supposed to find P. So the only equation which relates to this question is P equals IV, and we are given with V and I, so we can just find out our power. So it's going to be 12 into 0.35, which is going to be 4.2, and it's going to be watts as unit. And we are done with question number 8. Question number 9. Figure 9.1 shows a circuit with 3-position switch. The moving part of switch is always connected to point Y. around which its pivot. The other end of the moving part labeled X can be connected to one of the points A, B, or C. Part A says the resistance of the motor is 2 ohms and the resistance of the resistor is 3 ohms. Determine the current in the motor when the switch is connected to point A. So we can see here, this is the diagram. I just moved it down. So when it's connected to point A, there is no potential difference. So our current is gonna be 0. And don't forget the units, which is ampere. When it's connected to point B, there is potential difference of 12 and there is resistance of motor which is 2 ohms. So we can find out our value of I, which is going to be V equals IR. I is going to be V divided by R. So it's going to be 12 divided by 2, which is going to be 6 ampere. When it's connected to point C, you know that there is a resistor which has resistance of 3 ohms and the motor has resistance of 2 ohms. So we will have a new resistance which will be 2 plus 3, which is 5 ohms. So we can find out our new value of current, which is going to be I equals 12 by 5, which is going to be 2.4 ampere. Part B says two resistors of resistance 2 ohm and 3 ohm are connected in parallel. Calculate the combined resistance of resistors in this arrangement. So we have the formula for resistors connected in parallel, which is R1 into R2 divided by R1 plus R2. So we can use this formula here, R1 which is 2 ohms into R2 which is 3 ohms divided by 2 plus 3, which is going to give us our answer as 2 into 3 divided by 2 plus 3, 1.2. So we have our new resistance of 1.2 ohms. And we are done with question number 9. Question number 10. Figure 10.1 is a simplified diagram of a digital circuit. The output of the logic gate Y controls a buzzer. There are two inputs, input A and input B, and we're using a NOT gate here. This is NOT, and this is a NOR gate. Part A says complete table 10.1, the truth table for the circuit. So we can see here for output X, which is this, we have input of A. So we can take input of A, and as the gate is NOT gate, it's going to be opposite of the input, which is going to be 1 1 0 0. And the second one is going to be for Y, in which Y takes X as input and B as input. So these two are the inputs, and as we know, the gate is NOR, so it's gonna be opposite of OR gate. So when we can just write the outputs of OR first, which is gonna be 0 plus 1, which is 1, 1 plus 1, which is gonna be 1, 0 plus 0, which is gonna be 0, and 1 plus 0 is gonna be 1. And as it's NOR gate, the output is gonna be opposite of OR. So our new outputs are gonna be 0 0 1 0. Part B says input A is the output of humidity sensor, which gives logic 1 when the humidity is high and logic 0 when the humidity is low. So we can see here this blue is gonna be for high, and this peach is gonna be for low. These two input gives us low, and these two inputs give us high. And then it says input B is the output of a light sensor, which gives us logic 1 in bright light and logic 0 in darkness. The buzzer sounds when the output of Y logic is 1. So we can see here that for the second one, which is input B, 1 represents bright light and 0 represents dark. So this is going to be dark, dark, and this is going to be bright, bright. The question asks us, state the conditions of humidity and light when the buzzer is on. We can see that the buzzer is on when the output of Y is 1. So the conditions which match here is input A is 1 and input B is 0. We can write here when humidity is high and there is darkness. Only then we get output as 1. Part C says the output of digital circuit alone is not able to operate the buzzer. Ring the component from the list that must be connected between the outputs of the digital circuit and the buzzer. And we're given with some options here. Thermistor is used to measure temperature of any given device. Resistor is used to reduce current, and relay is used to change electrical current into high electrical current. And fuse is used for breaking the circuit when there's large or too much current flow. And heater is used to convert electrical energy into thermal energy. For this question, it says that the digital circuit is not alone able to operate the buzzer. That means the current is not enough to turn on the buzzer. So we need a relay for this question. And our answer for this question is gonna be relay, because it converts low electrical current converts low electrical current into high electrical current. And this is gonna be our answer for question number 10. Question number 11. Part A says figure 11.1 shows the path of 3 alpha particles moving towards a thin gold foil. 4 gold nuclei are shown. Path of alpha particle is also shown here. Part I says on figure 11.1 complete the paths of 3 alpha particle. So as we know, alpha particle is positive. So this is going to be positive, positive, positive. And gold foil are also positive, positive, positive. So what will happen is this alpha particle is gonna deflect back, because this is same charge and it's gonna deflect back when it goes towards the positive charge. This is gonna go and deflect on this side, and this is gonna pass through undeviated. Part 2 says state the sign of the charge on alpha particles. And as we know, alpha particles have positive charge. So we can write here positive charge. Part B says the nuclear notation for nucleus of gold 198 is this. State the number of electrons, neutrons, protons in a neutral atom of gold. And as we know, this is number of electrons. This is number of protons plus neutrons. And you know that number of proton and electrons are going to be same, so 79 and 79, and number of neutrons is going to be the total number, which is 198 minus the number of protons or neutron, which is going to be 79, and this is going to give us our answer as 119. And we are done with our question paper. If you found this video helpful, give this video a thumbs up. Do like, share and subscribe. See you in the next video.